Let's go ahead and set up our player character. In this game, our player is going to be a first-person character that we're going to be creating from scratch. To get started with that, we're going to go ahead and create a capsule to represent our player in the scene to get started. So go to Create, 3D Object, and go ahead and create a capsule. You'll notice that it gets spawned in the floor probably, and that's okay. All you have to do is zoom out, drag it up, and actually what you can do is just change its position to about 0, 0, 0, and you'll see it's in the floor right here. Let's go ahead and drag him up, and let's just go ahead and place him right here. Now, one thing I want to show you guys is we need a surface area to walk on, okay? And you'll notice that our scene environment, when we select it, our level, you'll see this like mesh collider that's green all along our floor. The reason why that's there is because when the designers at Unity were developing this in whatever 3D modeling program they used, they created a market mesh collider, which is a special collider designed specifically for this level. I want to go ahead and show you something. If you were to add a rigid body to this character, a rigid body, not 2D, just a normal rigid body, and we have use gravity check, watch what happens. Our capsule, when we run the game, is just going to fall and hit the ground. If we didn't have this collider here, we would fall right through the ground. Now we're going to actually have problems because this collider is only for the left and right, or I'm sorry, this collider is only for the floor of our game, not the actual sides, which means we can actually walk off this map. And to show you that, check this out. I'm fine, and then as soon as if you're looking in the scene view, as soon as I go off the map, we just fall through. So that's where we're going to get into navigational meshes in the next section. So here's our player, and this is going to represent, or here's our capsule, and this is going to represent our player. Let's go ahead and rename it to player. And let's go ahead and remove the rigid body, since we're going to be creating a physics-based character controller from scratch. To do this, we're going to be using the character controller component in Unity. So let's go ahead and take a look at that before we actually dive into creating this ourselves. Let's head over to the scripting reference by just selecting this little blue icon book. And what we're going to be looking at here is the character controller. And make sure you're in the scripting API. And actually this is the manual for it, but basically the character controller is mainly used for third-person or first-person player controllers that does not make use of rigid body physics, because we're going to be creating our own physics. So head over to the scripting API, type in character controller, and you'll see here that we have a character controller. These are the methods of it because I added a space here. Just remove that space. This is the actual component. A character controller allows you to easily do movement constrained by collisions without having to deal with a rigid body. Perfect. So here we go. Character controller allows you to easily do movements. A character controller is not affected by forces and will only move when you call the move method. It will then carry out the movement but be constrained by collisions. Great. And as you can see here, we have a move method. So already off the bat, how do we use the character controller? Well, we have to use the move method, which is right here. So a more complex move function taking absolute movement deltas. So basically this is a character controller that is going to move our player and have physics affect it without a rigid body, or collisions affect it. So let's go ahead and actually just jump through their code a bit and just see what they're doing here, because this obviously is a lot that's going on and it might be a little intimidating. What's happening here is they've just declared a speed variable for our player. The player can jump, and they've added a gravitational value. They also have a vector 3 move direction, so if you're moving forward, backwards, left, or right. Every frame and update, they're getting a handle onto the component character controller. They're checking if the controller is grounded, because you can only move if you're grounded, right? Imagine you're in midair jumping. Can you move if you're jumping? Absolutely not. So you have to check if you're grounded. From there, they're saying the move direction is based off your user input. We're familiar with the input get axis horizontal and vertical because we use those in game 1. That's how you actually get keyboard inputs, and they're basically applying them to the move direction of your choosing. Then they're saying here, move direction equals transform.transform direction. Now, if you're not sure what that is, we're going to get into this in a later video, but essentially this is how we are basically going from local space to world space, which we'll introduce in a later video. From here, move direction multiplied by speed, that's just your velocity, which is direction with speed. And then here they have logic for if you jump, and then they say your jump speed, which is 8, gets applied to your y value move direction. Here, they're applying gravity, which they created through this variable here, move direction.y minus equals gravity. And then the most important part is they're saying move. They call the controller, which is their handle, and they say move based on the move direction of your user inputs with real time by using time.delta time. Now, this could be totally confusing, and that's fine. Their example here is close to what we're going to do, but we're actually going to do something that I believe is a bit better, and it's also going to give you a better understanding for writing this from scratch. So I'll see you in the next video, and we'll go ahead and set up our player.